Hello everybody and welcome. My name is Arnold Uhl. I work for the company LUM in Berlin, Germany. There will be a brief introduction, motivation and some words on step technology for direct stability testing. Then I would like to discuss pros and cons of real-time testing with you, to be followed by the presentation of the combination of physical acceleration and temperature ramp for direct stability testing. Last but not least, there will be a summary. Real-time testing at gravity at the constant temperature is applicable for rather unstable pre-formulations, as we can see here on the example of an oil and water emulsion. These are animated GIFs for 70 hours of real-time separation. And we can see the first changes are detected by NIR to the left, near infrared 870 nanometers. In combination with the temperature ramp, real-time testing is a nice opportunity for cosmetic ingredients and to characterize the quality of cosmetic ingredients. Here we have a typical ramp from 30 down to 15 Celsius back to 30, which is applicable, for example, for coconut oil. And here to the left, we can see a clear coconut oil starting at 30 with a high transparency, with a high transmission, becoming then turbid once we reduce the temperature down to 15. And that is a full reversible process. The pure coconut oil becomes clear again when getting back to 30 degrees Celsius. If we compare this with a contaminated oil, we can see in the beginning there is less transmission, then there is some kind of a clarification due to the settling of the microparticle contaminants. It also becomes turbid at 15 Celsius, and then back to 30 Celsius it even becomes more transparent but still noisy, and we can identify there are still nanoparticles which have not been settled and which still scatter light. So temperature ramping and real-time settling is one of the opportunities for the characterization of cosmetic ingredients. Dish detergent measured as received, so without any dilution in a 10 mm cell and with the other conditions which can be seen here. Here a temperature ramp was applied from 20 going up to 55, going down to 20 Celsius. We can see here the transmission profiles, and we can see the non-shaded area in the center. This is the area we use for the calculation of the following results. Here we can see the temperature ramp performed, and here we can see the quantitative information, the integral transmission determined for the entire stages of the separation. And once we quantify the integral transmission rate, then we can see here the period 20 to 35, 20 to 40, at 45 and at 50, and we can see the higher the value of the rate, the quicker the formulation changes described. You're welcome to contact me later for any more details, or have a look at our website and look by keyword search for more application examples. I would like to thank you for your attention, for your interest in this talk, and I would like to acknowledge gratefully my colleague who performed the analysis of the dish detergent.